Rocket Fin Science Fair Project by Caison Rivera and Zachary Young. Our teacher is Miss Antonelli, and our school is Pioneer Hill. The problem that we aimed to solve in this experiment was, how do rocket fins affect the rocket's travel? Here's a project summary. Our project attempts to answer the question on how rocket fins affect the rocket's travel. We hypothesized that the rocket fins help keep a rocket stable and give stability during flight, and that the three rocket fins would keep the rocket stable farther than zero fins, one fin, or two fins. Our research and experiment, the evidence from both the research and experiment, supported this theory. Here are the 5 main points of our experiment. So the rocket fins must be the right amount in order for the rocket to fly right. The rocket fins are, if there are too little rocket fins, then the rocket will have very low stability, and it will just fall, and it will just be out of control. When you blow up a balloon and open balloon, and you just let it go, and it goes crazy and makes a weird screeching noise. Yeah, that's basically a rocket with zero fins, or too little, regardless. If there's too many rocket fins, then it will weigh down the rocket a lot, and it will just fall straight to the ground. And zero rocket fins will have no stability at all. Like no stability at all. Like the balloon on like the open balloon. Yeah, that's basically it. And also the one fin rocket will weigh it down, and also it won't provide a lot of stability at all. Also, it isn't wise to add any extra weight, so we had to scrap our original idea of attaching some kind of measuring device to the rocket. Because that would just weigh down the entire rocket, and in some cases it would be heavier than the rocket itself. So we had to scrap that idea. So instead, we used a different method to measure the height. Our control variables were the rocket size, the launcher, the setting of the launches. Every single one of them was in the same place. The number of rockets, and the tip of the rocket. Every single one had the same tip. The independent variable was the amount of fins on each rocket. Again, we removed them we removed each one for every time. And the dependent variable, that was the altitude that each rocket flew. Our hypothesis was, if we launch 4 different rockets, each with different rocket fin amounts ranging from 3 to 0, then the rocket with 3 fins would launch the highest. Alright, so our materials for the experiment were a rocket launcher, obviously to launch the rockets, a measuring stick, which we ended up using to measure it. We marked down the top, like the highest point of each rocket flight, and we measured that with a measuring stick, specifically a measuring tape. 4 foam rockets, the thing we launched, like the rockets. Hands, which we used for ripping off rocket fins. Obviously, we used it for everything else too, but in this case specifically, we wanted to prioritize the fact that we used them for removing the rocket fins, and that we didn't use scissors. And pencil and paper for recording the data, and which we would put on Excel later, and a 3-pound weight for launching the rockets. And from an equal height, to make sure that every single one had equal launch power. We wanted to make sure that everything had equal power, and everything was the same. And we also used some tape to make sure that we placed the rocket at the same spot, so that way we also had again equal launch power. So that was also a factor. It was used as a marker. So first we so the process that we used to do the experiment was, first we set up the launcher and everything. Then we cut off all the ripped off all the rocket fins for the rockets that needed the fins to be detached. Then we launched each rocket. launched each rocket. First we did the 3 trials, then we moved on to the next rocket, and then we recorded the data each time, and we put it on a chart, and that is it. Here's the chart that I was talking about. I'll give you a couple seconds to look at it. Well, you could pause it if you wanted to look at it a little more. So, but I'm gonna move on. Here are some of the pictures. Yes, that is my leg, my pants, and my socks. And yes, that is my house. That's the measuring tape that we use for both measuring the launch height and how high we were launching the weight. We were dropping the weight. That's the 3-pound weight, the purple thing right there. There's the tape to mark where we were placing the rocket. There's the launcher and the launching pad itself. Those are the rocket fins that were detached, and those are the actual rockets. And yep, that's it. And here is our conclusion. Fins keep the rocket straight. Fins keep the rocket straight and give it stability. Rocket with 0 fins had no control or stability. Our hypothesis. So basically, it was like when you blow up a balloon, but you don't open it and you let it go, and makes the loud screeching noise. Yeah, it was exactly like that. So yeah, it flew like crazy and went like a maximum of 7 feet. The rocket with 1 fin had low stability and the weight was unequal, so always drifted far in one direction and got a maximum of like 9 feet. So the rocket with 2 fins had good control and good stability and decent control, but like it always drifted a little at the end and got just barely a maximum of 18 feet. The rocket with 3 fins was near perfect with excellent control and excellent stability. The 3-fin rocket soared with an altitude well over 18 feet. 3-fin rocket was by far the best. Like, there was no competition. Our hypothesis was correct. Those are some of the sources we use for our research paper and the PowerPoint. The ones that are green with orange and underlined, we attach the links to them. And the Amazon one, that's the only one that's for the experiment itself. That's how we bought our materials for the experiment. The rest is just for the research and everything. Yep. And that is it. Hope you have a nice day.